In this lesson, we shall look at graphs and functions, but also aspects of algebra and related concepts that pertain the first paper. Right, we will recap on how you need to do basic algebra before we spend time on graphs and functions and also related concepts. But first things first, how do we solve for x given the question x squared plus x minus 12 equals 0? I'm doing these examples and I'm going to give you your own homework. I know this is way too easy. We have been given x squared plus x minus 12 and the result is 0. What do? We multiply x squared. We want to solve for x, but to solve for x, we first factorize this. And to factorize this, we multiply x squared by minus 12, getting minus 12x squared. And when we have minus 12x squared, we look for the factors of minus 12x squared that give x. And those factors are nothing other than exactly plus 4x minus 3x minus 12 equals 0. Factoring x, we have x plus 4 minus 3, open bracket, x plus 4 equals 0. You have x plus 4 in brackets, x minus 3 equals 0. And therefore, with x equals minus 4 or x equals 3. So these are the numerical values of x because we were looking at question 1.1 and therefore we have managed to successfully solve for x here. Where's a question? Or where's a contribution to make? If you have a question, please let us know. Just let me know if you have a question to say, hey, there's supposed to be a billion, but you've put a 4. It should be a trillion, but you have put a 3. Where's the question? A suggestion. Right. Do you understand this method of factorization? That is what I'm trying to emphasize today. Given this x squared plus x minus 12, this is how we factorize. But if you have a question, please, you're welcome to let us know. Next question. Right, the next question is question 1.2, and we want to successfully be in a position to solve for x, given this one. So we've been given 3x squared. Right, we've been given 3x squared minus 2x minus 6 equals 0. A equals 3, b is minus 2, and c is minus 6. Right, in which case, therefore, because the examiner says your answers must be written correct to 2 decimal places, and therefore we use the quadratic formula straight away, getting x equals minus b plus or minus the square root of b squared minus 4ac. Square root divided by 2a, which is, okay, so because we have that b is minus 2, so what we can do, we can put, okay, it's minus. The b is minus 2, plus or minus the square root, minus 2, 4a, c, all over 2a, which means x is 2 plus or minus the square root. Right, so if you look very carefully, then what do we have here? Right, so you're going to have exactly a 4. Because if you square minus 2, you get a 4. And you have actually here a 4 by 3, which gives us a 12. And 12 by 6 is equal to what? Because 12 by 3 is 36, so that gives us a 72. Gives us a 72. All divided by 2 by 3. And exactly 2 times 3 is 6, like so. And obviously, we proceed now to solve for x, but with absolute caution, because we are able to see that this is 2 plus or minus the square root of exactly 76, all divided by 6 in the denominator. Right, so this is what we have. But now the question is, I'm trying to get you to learn how to obviously be in a position to factorize this and to solve for x in cases like this. But obviously the notion of what we call the K method becomes very, very fundamental in the way we do our calculations. And therefore, we need to make sure that all goes very, very well. Okay, so now let us continue. Let us continue then to analyze these together. So analyzing this together now, what are the values of x? Well, it then means that at this point, we can even write in the green color. So x is 2 plus the square root of 76, all divided by 6. Or x equals 2 minus the square root of 76 all out of 6, like so. Okay, what is then the actual then central objective of this? If we therefore continue and solve this very, very carefully, what then are we able to get out of this? We were able to therefore see that we can divide the screen like this, getting x equals 2 plus. The number 76 is 4 times 19. And 4 times 19 gives us the square root of 4, the square root of 19, all divided by 2. Or x equals 2 minus the square root of 4, square root of 19, divided by 2. 2 the square root of 19. Okay, so if we divide here, it becomes exactly 1 plus the square root of 19, or x equals, this becomes 2 minus 2 the square root of 19, all divided by 2, and this becomes 1 minus the square root of 19. And now, upon careful simplification, we're able to see that at this point, we have the required numerical values of x, and what are they? Right, this side we'll be able to get 1 decimal comma 79, or use a decimal point. Here it's approximately minus 1. Okay, let's see here. This is the right. Just check carefully here in the denominator. You have exactly a 6 and a 6, making a huge difference. A 6 and a 6. Right, so getting a 6 and a 6 here, we have a 6 there and a 6 there. Dividing through by 2, okay, you still have the 6 here. And if you divide through by the 2, you'll get a different result here. You'll get a different result. Okay, you can do a lot of simplifications, and here you'll get a 6. Right, without wasting any time, using your calculator, you okay, obviously 2 divides into the 6, giving us a 3 in the denominator, but yeah, this is going to be decimal 1,79. And this will be actually approximately minus 1,12. Okay, so these are the results we get. So take your time to understand this, because in particular, when the examiner says correct you 2 decimal places, they have the understanding that this must be done using the quadratic formula. If you don't want to use the quadratic formula, we use what you call the method of completing. Method of completing the square. Okay, that is something that we discussed a little bit last time. The method of completing the square is very important for the grade 11 syllabus in particular. Okay, we continue to, okay, I'm just reminding the quadratic formula here, reminding everybody about the quadratic formula in its application. The application of the quadratic formula to actually solving quadratic equations. Let us look at the next point, 1.1.3. Right, 1.1.3 is this one, and it's a very, very famous. Okay, this one is a radical equation. It involves what you call the radical sign. That is called this sign is called the radical sign. Okay, this sign is called the radical sign. There you have that this equals the square root of 2x plus 1 equals x minus 1, and we're interested in solving for x. We need to remove the radical, and to remove the radical sign, we perform algebraic squaring. Algebraic squaring both sides of this equation. And the reason why we square both sides, please, you need to watch the video, replay the video during your own leisure, try each question, and do the homework I will send on papers 1 and 2 on the WhatsApp groups. So this one is 2x plus 1 equals. Right, so this radical sign is gone, being removed by the square, and we have here. Okay, pay attention to this and how we square binomials. You write x squared, like so. The next thing is x times minus 1, which is minus x times 2, minus 2x. You square the negative. Negative times negative. It's a plus. 1 squared. It's like 1 times 1, giving us a 1. X squared minus 2x. Bring down the 2x, which is like a 2x. Bring it across. It becomes a minus 2x. We already have a 1 on the right-hand side, but this one becomes a minus, and this is 0. X squared minus 4x equals 0. X minus 4 equals 0. X equals 0 or x equals 4. Okay, if you put x equal to 0 on the right-hand side of the equation, putting x equal to 0, you'd have 0 minus 1. So putting x equal to 0 would have 0 minus 1 giving a minus 1. In which case, if you can do a quick check and say 2 times 0 plus 1 square root is 0 minus 1. Check if this is true. The square root, 2 times 0 is actually what? It's a 0. Square root of 1 is 1. But this claims that this is the case, but 1 is not equal to minus 1, meaning you must remove this one. You must remove x equals 0, so x is not equal to 0, and then if you put 4, you check, putting 4 there, in the place you have 4, we have the square root of 2 times 4. Okay, there's a 2 times 4 here, like 2x. So you'd have a 2 by 4 plus 1, okay, which is equal to a 4 minus 1. Okay, 2 by 4 is what? It's exactly 8 plus 1. It's a 9. We have the square root of 9 here. 4 minus 1 is a 3. What is the square root of 9? It's 3 equals 3. Yay, this is correct. Eureka, we have got it. And therefore, the correct answer is only x equal to 4 and x equal to 0 is prohibited. So this one is invalid. Or if you don't want to say it is an invalid answer, you say it is inadmissible. It is an inadmissible result. It's not applicable. Not applicable. Okay, now we just need to write one comment there and move forward to the next question. Right, looking at 1.1.4, we proceed to solve the algebraic equations. This one is an algebraic inequality. And how do we solve x squared minus 3 bigger than 2x? We remind each other. I'm going to send you a homework at the end of our discussion immediately to make sure that you commence today and during the rest of the week. The homework is going to be very long. It's going to be a full exam paper. So you have the whole week to do it. I can't say do it now because you have your own other subjects to do as well. Okay, right. So this one must be written first in standard form. Right, to write it in standard form, the standard form is this one. So the form ax squared plus bx plus c equals 0 is called the standard form. The standard form, which is x squared minus 2x minus 3 is bigger than 0. So now we continue. We continue. Right, so to continue, we have the following. We have exactly the following. We need to factorize this because we just moved the 2x. The 2x was on the right-hand side. We moved it across to the left-hand side of the inequality, and therefore we have minus 2x. X squared times minus 3, which is minus 3x squared. And therefore we have x squared. Right, having minus 3x squared would give us minus 3x plus x. Then minus 3 is bigger than 0. And then you have x minus 3, x minus 3, which means that it is x minus 3 which means that it is x minus 3, x plus 1 is bigger than 0. Okay, so we're able to therefore get the following. We are able to get what we call the critical values. Right, what are the critical values? Right, given an inequality, we get the critical values, and what are they? They're namely x equals 3 or x is minus 1, and these are the critical values. And we quickly put them on the on this one here, and we see our beautiful smile, the smiley face. And this is going to have a minimum vertex, the associated parabola of this function, because of the positive coefficient of the quadratic term. And therefore, we have a minus 1, 3 here. And now, when we're interested in the part where this quadratic is greater than 0 is above here, and greater than 0 also is above there. And when that is the case, it means x less than minus 1 or x bigger than 3. So now we continue to solve this particular question very carefully. So this therefore becomes the answer to the question. So take note of this and make sure that you understand this. Make sure that you understand this very well. And hence we have, moreover, the following. We want to solve for 1.2, and 1.2 is a simultaneous equation. Solve for x and y simultaneously. How do you solve for x and y simultaneously? And it is what we do at the moment, but we do it with absolute caution. We have been given a couple of things, but we have been given x plus 2 equals 2y as one equation. So we've been given x plus 2 equals 2y. It is one equation. Can we make x the subject of the equation so that we have 2y minus 2? And this is the result. Okay, so you multiply xy, which is 1 over x plus 1 over y. And we have that. Okay, multiply here. The x cancels. Right, so xy. So what you do is substitute. Equation. Substitute equation 1 into equation 2. And doing so, x equals 2y minus 2. So you have y plus. In the place of x, what you put? 2y minus 2 in the place of x here. 2y minus 2 is equal to, in the place of x, you put 2y minus 2 in the place of x, and you have the y like this. 3y minus 2, which is 2y squared, minus 2y, which means this is 2y squared minus 5y. 2y squared minus 5y plus 2 equals 0. And what is this? We want to solve for x here. And what are the factors of this expression? To factorize this one, you multiply 2y squared by 2, and you get a 4y squared. What are factors of 4 that give minus 5? When added together, those factors are exactly minus 4y minus y plus 2 equals 0. Like so, in which case, you continue to factor out y from the first two, or just not just y, but the highest common factor, which is a 2y here, giving us y minus 2, but you also factor out a negative 1 from the last two terms, getting exactly y minus 2 equals 0. So you have y minus 2 and 2y minus 1 equals 0. And this is exactly y equals 2, or y equals 1/2. You've got two values of y, and then we want to get the corresponding values of x, which means x is equal to, okay, we are using 2y minus 2, which means x is going to be 2y is 2 minus 2, and this is exactly 4. Okay. So it is 2, and then y is 1/2 minus 2, 1 minus 2, which is minus 1. Okay. Right, in which case you have this. You have this. Okay, and therefore, okay, yeah, so this is the case. So what are the values of x and y at this point? So we are able to specify the values of x and y. So in other words, you have that either y equals 2, right, y equals 2 or y equals 1/2. Okay, so x here is 2. Right, x here must be 2, because 2 times 2 is a 4. A 4 minus 2 is a 2. Obviously, this one here is 2 cancels 2, giving us a 1. And then 1 minus 2 is a minus 1. So in other words, we're saying either y is 2 or y is 1/2. Either x is 2 or x is minus 1. These are the actual values of x and y. And we've been able to solve these simultaneous equations very well. So if you have a question, please ask. If you have a contribution to make, a suggestion, you let us know that, hey, I have a suggestion here, and let us discuss it together. We are open to that. We are open. We are very open. The next question is yours. I'm giving you 2 minutes to try it, like a minute. 1.3, get started quickly in your book. Try question 1.3, and I'm gonna ask for the answer. Given 2 to the power m plus 1 plus 2 to the power m equals 3 to the power n plus 2 minus 3 to the power n, where m and n are integers, determine the value of m plus n. So let us find these here. Let us find these here. Quickly. 1 minute, less than a minute. I need the answer. I need to know how quickly we can do this question. And then we shall mark right now and make sure that all is well. Okay. Please. Please, 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 my friends. Please, please, please. How far? Okay. Okay, let us get started with this question because I know that you're smart and possibly have got the answer. 2 to the power m plus 1 plus 2 to the power m must equal 3 to the power n plus 2 minus 3 to the power n. So at this point, this is 2 to the power m, 2 to the power 1, 2 to the power m, 3 to the power n, 3 to the power 2, 3 to the power n. 2 to the power m is a common factor, and you have 2 plus 1 equals 3 to the power n, and then 3 to the power 2 minus 1. 2 plus 1 is a 3, so that you have 2 to the power m, 3. 3 to the power that, and then here you have exactly 3 to the power 2 is a 9 minus 1, 8, like so. And then right now, this is exactly 2 to the power m, 3, 3 to the power n, 2 to the power 3. Okay, so we look at this right now, and which is 2 to the power 3. Right, you write exactly 2 to the power 3 here. And so what do we get at the end of these? Right, we compare the powers. We compare the exponents, and this then implies that the power of the 2, so m is equal to 3. We're just comparing powers because we're looking for integer solutions. So we can actually realize that m can take the value 3, and also n can take the power 1. And therefore, we have the m plus n, which is 3 plus 1, which is equal to 4. And this means, therefore, that m plus n equals 4. Okay, we've determined the value of m plus n, and m plus n equals 4. Okay, there's a question here. Who does not understand what has happened? Okay, these kinds of questions, you must learn how to do them, but you must watch these videos, and you pause the video. When you're watching it, you pause it, because I'm going to pause this video. I'm going to make it available at the end of our discussion. You pause it, and you first watch and make sure you understand, and then you try the question without looking at the answer, without watching the solution, and then seeing if you can do it. And that is how you learn mathematics. Mathematics is learned by trial and error. It's not, you're not born able. You try. You're not born an athlete. You're not born a soccer player, but you are made through training. So this is our attitude. And so this is very, very important for you. Very, very important for you. Let us look at the next question. Right. So now, the next question looks at a graphical representation of an exponential function. This exponential function is surprising many, but it is appearing at grade 10, at grade 11, but then also in the matric syllabus. So it is very, very important, but critically important. I want us to pay particular attention to this question. Sketched below is the graph of f of x equals to the power x minus 4 for x between minus 2 and 4. A and B are respectively the y and x intercepts of f. Here is A and here is B. We can see clearly that A is the y-intercept and B is the x-intercept of the function f. We can see the domain restriction of this particular function. Now, what then is the next thing to do? Right, the next thing to do is to determine, the examiner is saying, write down The examiner here is not saying calculate or determine. They're saying write down. So if they say write down, it means you can just look and see and write down the equation of the asymptote of f. Anyone home? F is this one here. What is the asymptote? If f is f of x equals 2 to the power x minus 4 for x between minus 2 and 4, tell us, please, share with us, what is the equation of the asymptote of this function? Anyone, quickly. Grade 10. Grade 10 work. I know you're not in grade 10, you're in grade 11, but yeah, what's the answer? Quickly. What is the equation of the asymptote? What is the equation of the asymptote? What is it? Hello? No one knows. Okay. Right, the equation of the asymptote is clearly seen. It's that number. So if you have f of x, right, which equals 2 to the power x minus 4, the minus 4 becomes the asymptote. And therefore, the equation of the asymptote is the number minus 4. In this case, in our 4.1 analysis of this, we're able to see clearly that the equation of the asymptote is y equals minus 4. It is actually this equation of the horizontal line, but it is y equal to minus 4. This is the equation of the asymptote of f. Now, the asymptote of f is that straight line which the graph of the function will never touch. It will never touch the asymptote, but it will always continue to approach the asymptote indefinitely. And this is what we call an asymptote. It is nothing other than another curve that the function never touches, but continues to approach as we go as further away as minus infinity, and also as you go further away as plus infinity. Okay, my goodness me, like so, like so. We continue to examine the next point. And the next point is not at all different. So you need to determine the coordinates of B. We need to determine the coordinates of B. Right, so the coordinates of B are as follows. The coordinates of B are as follows. And what is B? To find the coordinates of B, we need to know that B itself is what? Is an x-card of the graph. It is called an x-intercept. How do you get an x-intercept? You let y be 0 here, which means it's 2 to the that. When y is 0, so what is x? So when x is when y is 0, x is 2. So this is the point. The coordinates of B are 2 and 0. And they occur when x is 0 because y. When y is 0, x is 2. So we have that the coordinates of B are 2 and 0. And we can see clear on the graph that B is nothing other than the x-intercept. It is the x-intercept of the function f. And to get the x-intercept, we simply let y be 0. Right, where's the question? Who is confused? Who is lost? Who doesn't know what to do? And who knows what to do? Right, so if you know what to do, or you don't know what to do, please let us know. Please let us know. Please let us know. Right. Right, so yeah. Right, we continue. We'll continue. I want us to continue looking at question 4.3. In question 4.3 is what remains very important for us. And want to look at that question, but very, very carefully, and we proceed as follows. 4.3. Determine the equation of K, a straight line passing through A and B in the form that straight line, determine the equation of a straight line passing through A and B in that form. Okay, now if there is a straight line passing through A and B, there are a couple of things, therefore, that remain very important. We've seen that the coordinates of B here are 2 together with 0. And this one is called the y-intercept. Y-intercept occurs when x is 0, and when x is 0 on the graph, in other words, you need to look at the fact that at A and A is the y-intercept. Right, look at the y-intercept, we let x be 0. So that we have x is 0, and x is 0, you have -4, 1 minus 4 is -3. So that in the end, then you have A has the coordinates x equal to 0 and y equals -3. Right, so that A now has the coordinates 0 and -3. 0 and -3. And therefore, now to find the coordinates which are of A are 0 and -3, or rather, we've already found them. And so we're able to continue and find the gradient. And what is the slope of the line AB? Moving from A to B is x1, y1, and this is x2, y2, and therefore we're able to find the gradient. The gradient of AB is a change in y, change in x, and change in y is y2 minus y1 over x2 minus x1. Like so. Over x2 minus x1. And y2 is a 0 minus y1 is -3, x2 is 2, x1 is 0. So you have y minus y1, which is m into x minus x1. In which case, therefore, it is exactly y minus y1, which is a -3, equals m, which is a 3 over 2x minus x1 is a 0. Which means y is 3 over 2x. This is plus 3, and then you put a -3 over there. This is the equation that the examiner wants. But now let's take a look at this equation the examiner wants. So the equation the examiner wants is actually k of x, which is 3 over 2x minus 3, and this is the equation. So in the end, then you have this here, k of x is 3 over 2x minus 3. So we continue right now to therefore solve the next question, because we've done question 4.3 And look at the question 5.3 very carefully, but make sure that you understand what is happening and make the most of your understanding there. Let us continue to analyze this moving forward. Looking at the next question. Right, so we have the next question. We have the next question. We have the next question. What is the next question? What is the next question? Okay, we move to the next point. Right, so the next point is question 4.4. In question 4.4, the examiner is asking us to calculate the vertical distance between K and F at x equal to 1. Right, to calculate the vertical distance between K and F at x equal to 1. So we have already seen K, and K cuts through the function. It has the equation K of x, which is equal to 3 over 2. And we have f of x, which is 2 to the x minus 4. And then now we want to find the vertical distance at x equal to 1. Now, we know the coordinates, for example, at B. The coordinates of B are 2 and 0. Meaning x equal to 1 is the vertical line here, and it is x equal to 1, and we're interested in. So it cuts this, each graph at one point. It cuts a straight line at one point, but it also cuts the exponential function at another single point. And so we need to therefore compute. Now we're dealing with 4.4. We need to compute K. Now we have that K of x is 3 over 2x minus 2. Evaluating K at 1 is 3 over 2 times 1 minus 2. And 3 over 2 is 3 over 2 minus 1. That is 3 over 2 by 1. It's 3 over 2, but if you subtract 2 from that, you get exactly what? You get exactly, so yeah. Let's see what we have here. Yeah, so it is 3 over 2x minus 3. 3 over 2x minus 3. So it is 3 over 2x minus 3. So this one is actually a minus 3 here. In which case, therefore, you put a minus 3 there. Okay, your homework is coming. I'm going to post it on the group, and you're going to try for the whole week because it's going to be very long. I don't want you to dodge your classes doing the homework. The homework is there to train you, to test your understanding. So now, okay, I was saying 3 over 2 by 1. So it is 3 over 2 minus 3. At this point, you can just multiply 2 times 3, getting a 6. So it's 3 minus 6 over 2, and 3 minus 6 is what? Is minus 3 over 2. So yeah, you're getting that. So in other words, at x equal to 1, you can see that y is minus 3 over 2 for the straight line. So you can do this and put minus 3 over 2 there. You continue now to also evaluate the f at x equal to 1, meaning f at 1, which is 2 to the power 1 minus 3, and this is minus 1. Rather minus, okay. Okay, watch out that this here is 2 to the power, is 2 to the power x minus 4, 2 to the power x minus 4, so that you have 2 to the power 1 minus 4, and this is a minus 3. Right, so you have here a minus 3. So yeah, let's continue. Yeah, so what are we doing here? Right. Let's just emphasize therefore that this is to the power 1, which is 2 minus 4, and this is a minus 2. Anyhow, when these guys intersect here, you have a minus 2 here. So this one here sitting there is a minus 2, and it is a y value. So then the vertical distance, right, then the vertical distance is actually equal to, now you subtract, now to find the vertical distance, the distance between two numbers, you say the largest minus the smallest one. So you need to say the largest number minus the smallest number. What is the largest number? The largest between minus 3 over 2 and minus 2. Because both numbers are negative, the largest one is minus 3 over 2. Because if both numbers are negative, the largest one is the one of the smallest size, of the smallest magnitude. At this point is minus 3 over 2, minus the smallest one, which is a minus 2. Getting a minus 3 over 2 plus 2. Okay, so yeah. And this is actually minus 3 over 2 plus 2. And what is minus 3 over 2 plus 2? Minus 3 over 2 is like 1.5. And obviously this is actually 1/2. 1/2 units. 1/2 units. So yeah, we're interested in the vertical distance. And therefore, so we continue. Right. Right, we continue. Right, so you look at this carefully. I mean, if you have a question, let us know. If you see a typo somewhere, there's something missing, there's something we need to add, you just let us know. But now we're able to see that the vertical distance is actually 1/2 units. We can say 0.5 units, but the 1/2 is just good enough. It is just good enough. We look at the next question, 4.5. Right, in 4.5, we need to write down the equation of g if it is further given that g of x is f of x plus 4. What is then the equation of g? G itself is a new function, and the new function is formed by the addition of 4 to the function f. So we have the function g, which is f of x plus 4, that f of x is 2 to the power x minus 4 plus 4, which is 2 to the power x. Which means that we have g of x, which is 2 to the power x. So, this is exactly what we got. We are taking the function f of x, and the function f of x was given here by the examiner. The equation of f of x is 2 to the power x minus 4. And we take the new function g of x, which is f of x plus 4, f of x plus 4. The f of x is 2 to the power x minus 4 plus 4, and this 2 to the power x. And this implies, therefore, that g of x is the function to the power x. Write down the equation of g if it is further given that. So the equation of g is g of x is 2 to the power x, and that's all. And that is all. Nothing more and nothing less. Nothing more and nothing less. But note that this is how we're doing 4.5. Let's look at the next question, 4.6. But now I want to also mention that this one, the examiner did not quite make it mandatory to state the domain, but this function g of x is also subject to the domain of the function f of x, because the domain itself is clearly between -2 and 4. So that here our x is clearly between -2 and 4, like so. -2 and 4. So obviously, I mean, we have this function, but it is a function that is stated that, right, we continue. We continue. All right, we continue. Right, in continuing, the couple of things that are very important for us to take into account, but please, folks, just make sure that you are very much attentive here and you're able to understand this. Let us look at 4.6. In 4.6, you need to write down the equation of the inverse of the function g. The inverse of the function g. Right, so the inverse of the function g obviously is can be obtained. Now, who can give me the inverse of the function g? Here. Anyone? Anyone home? The inverse of the function g is very straightforward. So now, the inverse of the function g, first things first, we need to look at the fact that the function f of x is equal to 2 to the power x minus 4. And so to write down the equation of the inverse, g inverse, we need to note a couple of things. Right. We need to note a couple of things. We need to note what we got the g to be, and without wasting time, we got g to be this. When g was obtained, it was obtained subject to the domain of this function, and the domain is -2 to 4. Right. So, right. So now at this point, we have the following thing. We have the following thing. And we are able to see, therefore, that the function g of x, the function g of x, is this exactly. The function g of x is 2 to the power x, but it is 2 to the power x simultaneously with the fact that there is what you call a domain restriction. It is 2 to the power x, where x is an element of the interval between -2 and 4. Between -2 and 4, like so. And if this is true, what is the domain of the inverse of g? Well, the domain of the inverse of g is obtained by taking into account a couple of stuff that are pivotal for us. So, to find the inverse of g, students, this is what you need to do at grade 11, but also at grade 10, and also at matric, and also beyond. We need to, now to find the domain of the G inverse, we actually, obviously, the examiner did actually not say that we need to write down the equation of the inverse yet. But they just said write down the domain of the inverse. So you can see, therefore, that we have already stated that G itself has the domain -2 and 4. So now, as its domain in that, but now what is the range of G? So we're going to write down the range. Right, we're going to write down the range of G. So the range of G is Y, which is an element of the interval. When X is -2, then you get the range. Right, when X is -2, you get the range, and this is X -2 like this. And then you have also 2 to the power 4 for the range of G. Right, and this is Y, which is an element of this negative power can be written like this, and 2 to the power 4 is a 16. Okay, this is 16 is excluded because 4 is having an open circle. Now, -2 has a closed circle. So take that into consideration, but also so that here you have round and round, because this one is a solid circle. Then we have a square parenthesis there, but here you have a round parenthesis. Okay, and therefore our Y is 1, this one is 1/4 16. Okay, right. Okay, what is therefore now the domain of the inverse? The domain of the inverse becomes the range of these. So, which means, therefore, the domain. Here you write the domain of G inverse. The domain of G inverse is X, which is an element of the interval. 1/4 and 16. 1/4 and 16. So now you take the range of G. The range of G was obtained. How did you get the range of G? We took the Y value of G, which was like Y equals 2 to the power X. And we substituted the end points. These are called the end points of this interval. End points, we substituted everything, and we got the answer. So if you don't want to write it like this, right, so we continue. We continue. We continue. If you don't write it like this, you can write it in the green color, and you can write it here. Okay, so we come here, and this is actually 1/4 less or equal to X less than 16. So you can write the domain can be written like this. X is an element of the square bracket, 1/4 semicolon 16 close round bracket. Right. Right. So we continue. So we continue. We continue. So yeah, you can write your answer like this or like this. This is the domain. Domain is set of x values, and these are the set of all x, which is an element of the um, square bracket, 1/4, and 16 open bracket, or you can write like this, where x is greater or equal to 1/4, or x um, is strictly less than 16. Okay, so the couple of things now that we need to do, but also we continue to look at the next question. So you need to write down the equation of G inverse in the required form. Let us look at G inverse equation. Let us look at the equation of G inverse. The equation of G inverse. Okay, now in 4.7, to write down the equation of G inverse, we first write down the equation of G, please. We will remember that in this question, our G of x, because it said write down the equation of G if it is further given that, we saw that G was 2 to the power x, whenever x is this one here, an element of the close bracket minus 2, 4. So G is y equals, G has the equation y equals 2 to the power x. So G of x is 2 to the power x, where x is an element of the interval between minus 2 and 4. And now you need to have the inverse. How do you get the inverse? Right, to obtain the inverse, we swap the rows of x and y. Wherever there is a y, we put an x. Wherever there is x, we put a y. Okay. With this mentioned now, we just solve and make y the subject of the equation. And if we make y the subject of the equation out of this, so you bring the 2 down so that you have the log of x base 2 equals y. Okay. Now, then we have G inverse. Okay, G inverse. So this one now is our G inverse. It is the new y, and the G inverse has the equation, the logarithm of x base 2, and x therefore is an element of 1/4 here and 16. 1/4 here and 16. 1/4 here and 16. Right, so we continue. We continue. We continue. So, this one obviously said write down the equation of G inverse in that form, and therefore the equation of G inverse is the log of x base 2, where x is an element of the interval 1/4 to 16 round parentheses, like so. Okay, round bracket and square bracket, these are the very important distinguishing brackets, and the examiner used them because the examiner said x an element of the of the square bracket minus 2, and then semicolon 4 round bracket there. And obviously we have to write down the equation of G inverse. How do you find the equation of the inverse? We just first write down the equation of G, and then wherever there is y, we put x to find the inverse. Wherever there is x, we put y, and this is already the equation of the inverse, but it is standard practice to just, like in grade 10, learn how to make y the subject of the equation, and if you make y the subject of the equation, this is what we get. This is exactly what we get. Okay, so we continue. We continue. So we look at the next thing. We look at the next thing. Right, you look at the next thing. Okay, let me see what arrows we need to sort of mention. Obviously, we need to understand that the domain. So we write down the G inverse like this, and we say X is an element of 1/4 to 16 because we stated here the domain of the inverse. The domain of the inverse was from 1/4 to 16. We got it step by step previously, and that is why we just now just obtain the equation of the inverse and then just put the domain next to the inverse equation. But now we did not just guess this domain here. We do not just guess the domain. The domain is the set of x values for which this function itself is defined. But you see, look, we did not just guess this here. We didn't. We worked it out. But step by step. But step by step. So we look at the next thing. Right, the next thing is a very interesting graph question, and we're looking at graphs and functions, but graphs and functions remain at the heart of mathematics. And so we need to master the graphs. Now, the graphs of f of x equals minus 1/2 x, open bracket x minus 1 squared plus 8, and the g of x equals d over x are drawn below. So we have the graph of f, and the graph of f is nothing other than this parabola, and we also have the graph of the rectangular hyperbola, which is the graph of G. A point of intersection of F and G is B. B is the point of intersection. The turning point of F, it is also the turning point of F. The graph F has x-intercepts minus 3 and 0, 5 and 0. And the y-intercepted C, y-intercepted C, y-intercepted C. Write down the coordinates of the turning point of F. Who can give us the coordinates of the turning point of F? We're looking at 5.1 because we already know that f of x is minus x minus 1 squared plus 8. Okay. So now we study what we call a parabola. For us, a parabola has two significant representations. The standard form of a parabola, which is x squared plus bx plus c. This is called the standard form of a parabola. But also a parabola that is written in what we call the standard form. But the parabola can also be written as what? The parabola can also be written as a open bracket x minus p squared plus q. And this one here is called the vertex form of the equation of a parabola. This is called the vertex form. And this is called the standard form. The standard form is x squared plus bx plus c, but the vertex form is y equals a open bracket x minus p squared plus q. The parabola we study has these two forms. We will recall from grade 10 that, but none of us in grade 10, that we have y equals ax squared as the equation of the parabola we study. And so, the couple of things, therefore, that remain at the heart of the operations. The examiner either gives the equation in the standard form or they give it in the vertex form, but they gave it in the vertex form. This vertex form has the coordinates P together with Q as the turning point. Is the turning point, which is the vertex. So now if you have been given the form y equals a open bracket x minus p squared plus q, and which is the form the examiner gave, then they are saying find the coordinates or write down. Don't calculate. Don't take many steps. Just one step. The coordinates of the turning point of f and the coordinates of turning point, we just pick them. If it is minus, so we just pick the p and the q. So here we would find the 1. We just pick, because it's minus, you just pick 1, and you pick the number with its sign, and you pick 8, and these are the coordinates of the turning point. But these coordinates of the turning point have this what we've been asked to get, and we have actually been able to get that with ease. We've been able to get that with ease here. We've been able to get that with ease. All right, so we move on to the next question. In the next question, we want to calculate the coordinates of C. C is, now, if they ask you in the exam, you see many students ask the question, how do I find the coordinates? If they say calculate the coordinates, what is the formula for finding coordinates? That is one popular question many students ask. But now, the formula for finding coordinates is the formula that is used to deal with the nature of the point. This one is the y-intercept. So in 5.2, they're asking for us to find the coordinates, but this is the y-intercept. Okay, if this is the y-intercept there, that's what you need to find. So the question in 5.2 is, how do you find the y-intercept? Okay, to find the coordinates, you might just find the y-intercept, because C is the y-cut. It's where this graph intercepts or cuts the y-axis. So how do you find the y-intercept? To find the y-intercept, we clearly let x be equal to 0 in the function. F of x is this one here. So it's f of x equals minus 1/2 minus 1 squared plus 8. F of 0 minus 1/2. 0 minus, you must watch this video again in practice, please, folks. This is not child's play, it's reality. 0 minus 1 is the minus 1, you square minus 1, you get a 1. 1 times minus 1/2, you get minus 1/2 plus 8. You put a minus 1 like this on your 8 fractions like this, when the other one is not a fraction, say 2 times 8. 2 times 8 is a 16 over 2, and this is 16 minus 1, which becomes 15 over 2. You already know that x is 0 and y is 15 out of 2, which means the coordinates of C are, you start with the x, which is equal to 0, and then you end last with the y, and the y is 15 out of 2, and these are the coordinates of the point C. And you can even come to the graph here and say your x is clearly 0 and y is 15 out of 2. And these give us the coordinates of the point C. Then what is the next thing that we need to do? We need to continue to solve more problems and to make sure that we pass very well. Now, the next question is calculate the value of D. Calculate the value of D, and D is there. D is the numerator of the rectangular hyperbola. How do you get the numerator of the rectangular hyperbola? How do you get the numerator of the rectangular hyperbola? To get the numerator of the rectangular hyperbola, we proceed as follows. So what do we do, good people? We attempt to use a point on which or a point that lies on the graph, a point through which the graph passes. So now can say the function passes through a point. So now let us look at 5.3. Right, in 5.3, there are a couple of things that remain very key. What are the things that remain very, very key? Right, so we are trying to ensure that we learn together, and the point through which the rectangular hyperbola, here's the hyperbola here. This is one part of it. This is another part of the rectangular hyperbola, but there's no point whose coordinates we know here. But there's a point whose coordinates we know. It is the point B, and the point B is the turning point, and we just pick one. We just pick 8, like that, from the what we call the vertex form of the equation of a parabola. Okay, so you have 1, 8 from the vertex form, and therefore this point is a common point because it is a point on it is a point on each graph. Okay, so we have g of x, which is d over x. This is x and that is y. And y is 8. And we have d over x is 1. D is 8 by 1, which is actually 8. So we took the equation of g and wanted to find the value to calculate. So we had to show some steps to calculate the value of d in this question. And we had to write down the equation that contains d, that is the first step, and to find one point on the hyperbola, and the point is 1 and 8, through which the function, the rectangular hyperbola passes, and we pick the y, which is 8, and then x, which is a 1, and we cross multiply, and we got d equals 8. And the examiner said calculate the value of d, and clearly we got that d equals 8. Right, you'll forgive me if I lose you. I did not realize that I'd lost Pekelelo there, or we'd lost Pekelelo. It is obviously our sincerest apologies. If I lose you, it can always be due to the network. But once again, we are growing, and our attempt is to use more connection methods like your Microsoft Teams as well, on top of the use of the Zoom system. Okay, 5.4 is next. In 5.4, we want to write down the range of G. In 5.4, we need to write down the range of G. Right, so the range of G becomes nothing other than the set of x and rather the set of y values for which this function is defined. So if you look at the function g, which is actually g of x equals 8 over x. And so now we want to find the range of this function. And how do you find the range of this function? So this function here is what we'll learn. Okay, so our rectangular hyperbola is of the form a over x minus p plus q. That is one form, but also some teachers teach x plus p plus q like this, or sometimes they use a minus here with a plus there. So the range of this function here is always of the form. There's a formula for the range that we use, okay, because I know you are still going to the graphs and functions there, and we shall also spend a bit of time on the graphs and functions. We're just having a feel of these here. So which means that now if you want to find the range here, you need to say it is y element of R, but y is, you just say y is not q. Y is not q. Here there's no other number next to this. So normally this becomes a formula, but the examiner gave us a small one in this exam. This is a past exam question. So, but we can put some zeros here because this x minus 0 and the 0. Now, if you put the zeros, what do you get? Okay, so to write down the range, then we will come and then say, okay, we just need to remove because the range is to do with the set of y values, but this is y equal to 0, and it's also called the x-axis. So the range would therefore be y, which is an element of R, but y is not 0. That's all. So the range is y, which is an element of real numbers, where y is not 0. So yeah, something you need to take note of there and take that is very, very important. So in 5.4, it says already, you say therefore the range of G. The range of G is actually y, which is all real numbers. You start by saying it's all the real numbers because the y takes all the real numbers and you proceed to minus infinity, but you go up to plus infinity as you go higher and higher. So you say the range, therefore, is all the real numbers right through to minus, or from minus infinity. You start from the smallest one, from minus infinity to the largest one, which is plus infinity, but you indicate here that y is not 0. Why is y not 0? You always say y is not what is added there. If there is a general number, like the examiner sometimes gives you 5 over x minus 2 plus 3, then the range of this one, you just say that y is an element of R, but y is not 3, and this becomes the equation of the, or this becomes rather the range of the rectangular hyperbola. Okay, we continue to analyze more mathematics together. Let us look at the next point. Right, so the next question is as follows. We want to right now answer the question 5.5, and it says for which values of x will the product of the two functions f of x times g of x be less or equal to 0? For which values of x will the product of the two functions be less or equal to 0? Okay, so this boils down to really saying you are multiplying two numbers, f of x times g of x, and the result is negative. So it's like you're multiplying a negative number times a positive number, and the result is a negative. Okay, when you say less than 0, less equal to 0, you're dealing with the negative. Okay, so similarly, that is negative or 0. Less or equal to 0. Or you're multiplying a positive multiplied by a negative, and you get a negative, and this is less or equal to 0. So when you're multiplying two numbers, either the first one is negative and the second one is positive, because negative times positive is negative. Less or equal to 0 means the result is negative. Or you're multiplying a positive number times a negative number, and you have a negative result. In which case, therefore, want to find the values of x for which this is true. Right? It's interesting that I keep losing Pechelelo there. I don't know why. I don't know why. It's just a network thing. I don't know why I lose you, Pechelelo. Please forgive me. I don't know why I lose Pechelelo from time to time. I think it's the network. So yeah, you'll forgive me if that happens, because yeah, it should not happen. Ah, okay. So let's continue and analyze these questions. Please, if I lose you, you need to try and join, because this is very important. Why I have to go deep into functions, because functions are a little bit tricky. Sometimes the students struggle with functions, and it's very important that you understand functions very, very well. I'm very conscious of the fact that I'm dealing with grade 11s whose minds are still very soft on functions, and you are still more of the children who live on milk. The newborn babies, or they live on milk because it's still too young. 5.5, now we are looking at these two functions, and we're going to look at the fact that this function is negative because it is below the x-axis. This function is also negative here, but the function becomes positive all the way, positive all the way, like so, positive all the way, and then negative down, and then here are positive, positive, like this. Okay, I'm putting this signs, and also this one, let's just put for the, is positive. Positive means that it is above, because y is a big positive here, y is negative there. Or y is negative also, negative. Positive numbers, positive numbers, positive numbers, positive numbers, positive numbers. There on the y, you can put the numbers there. Okay. So putting the signs, too many signs like this, we want to analyze this, but analyze this very, very carefully. And thanks a lot, Pekhalelo, for joining us. Please, urging you guys to join us more frequently. We shall have more mathematics during the week moving forward towards the June exams. We need to make sure that you improve your math marks, but we shall have more practice exercises. As said already, I'm going to send you homework on the group, on the WhatsApp group, so that you can practice more mathematics paper 1 and paper 2 in preparation for the June exams. They are here, they are here, they are here. And guys, there's never time, please. There's never time. And before you even know it, it's going to be December now. And I want you to guys to master mathematics. For each of us of X will this be the case? So there are a couple of things, therefore, that are very important. You need to look, okay, to get the answer 5.5, you need to look for parts where one function, so one is negative and the other one is positive. So, and or the other one is positive and the other one is negative. So you must look for places where the two functions have opposite signs. When one is negative, when graph is negative, the other one is positive. When one graph is positive, the other one is negative. But here they're both negative, negative. And then here they're both negative, negative. Okay, so let's just cut the graph here a little bit, draw a vertical line with the ruler. If you draw with the ruler here they're both negative, negative, and here they're both negative, negative. Okay, but here one is positive and the other one is negative. One is positive, so they have opposite signs. One is your different signs. So, and let's see now. This is positive, 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 and this one is negative, negative, negative. Okay, and then now the okay, so now when you get here, it's up to here. Because at this point, this one is positive and this one is positive. Okay. So we are interested in where one is negative and the other one is positive or vice versa. So we're going to look at the following thing. We're going to look at -3 is less or equal to x up to 0. Okay, because now this function g, okay, this is the function g, this one, and the function g is of the form 8 over x, but you see this function g is undefined at 0 because it's division by 0. So we don't say x equals 0 here, but what we say is x, we have x equal to -3, x equal to -3. And then if x equal to -3, then it's okay because -3 is the x-intercept of the parabola. So, but now this one here is undefined at 0. So we continue therefore to simplify the things we have. Right. We simplify the things we have. So we continue as follows. We continue as follows. Right. We continue as follows. Right, so now to solve this once again, here one graph is positive, and the other one is negative, but it starts from 3 because if you go to the left of 3, then both functions are negative. And we want plots where they are opposite signs. So one is positive and the other one is negative. Right, so you have a positive here and one is negative there. Right, and then here at this point, they're both, if you reach the y-axis, this one is positive and that is positive. So positive, 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 positive. Okay, let's just check here also. If you cut here like this, both positive. And then at 5, to the right of 5, one is negative and the other one is positive. Okay, so let's just look at this one. Let us look at this one. Okay, let us look at this one. So this is the case, or x is bigger or equal to 5. Because to the right of 5, we have that as well. So you can write your answer like this, or you can say your x is an element of the interval minus 3, 0, union 5, 0. 5 infinity. Union 5 infinity. Because if you say x is greater or equal to 5, it means it runs all the way to infinity. It runs all the way to infinity. But now here you then say, because here x lies between minus 3 and 0, but because x is greater or equal to 0, then this bracket is square, and at 0 it is round. Union 5, it is square, and at infinity it is round. It's a round bracket. Okay, so that is something that you take note of. So we actually have solved this one to say for which values of x will this be the case. So you have positive, negative here, you have positive, negative. So these are the answers, and the answer is either you write like this, the answer to the question for which values of x will this be the case. You write either like this, or you write like so. Next question. 5.5, 5.6, calculate the values of k. Calculate the values of k so that h of x is minus 2x plus k will not intersect the graph of g. Right, so let us look at this. So if you look at this function and we are saying that h of x is minus 2x plus k. Minus 2x plus k. Calculate the values of k so that h of x equals to minus 2x plus k will not intersect the graph of g. Okay, now look at the fact that the graph of g itself is what? Is 8 over x. Obviously, it is d over x, but we got that d is 8. And we are then saying we are looking at this here whenever this function minus 2x plus k will not intersect the graph of g. So now we are looking at a case where, okay, if they intersect, then it means this. H intersects G. Okay. H intersects G. Okay, now look at this, guys. So H is what? Is minus 2x plus k. And G is 8 over x. Okay. What do we do here? We cross multiply. Minus 2x squared plus kx equals 8. Minus 2x squared plus kx minus 8 equals 0. Now want to solve this one? So, which means that our delta is b squared minus 4ac, and this is called the discriminant. Right, the discriminant is what we studied grade 11. And also now you just take your b is k minus 4, your a is minus 2, and your c is minus 8. Your discriminant becomes k squared, and you have here negative 4 times negative 2 is 8. 8 times minus 8 is minus 64. Okay, now if they do not intersect, if you say they will not intersect, it means that you have non-real roots. It means you have non-real roots. And if you have non-real roots, it therefore means that you are dealing with k squared minus 64 is less than 0. And you need to solve this one for k. The factors difference of two squares is k minus 8 into open bracket k plus 8, which is negative. Okay, you want to get the values of k, but now to solve for k here, we find things we call the critical values. What are the critical values? The critical values are k equals 8 or k equals minus 8. If this is the case, you'd have this here. Minus 8 together with 8, and this is k. So you're interested in the part where this is negative, negative, but here is 0, and therefore negative is at the bottom here. So which means, therefore, you have minus 8 is less than k, less than 8. And then now these are the values of k, so that this is the case. And the values of k, so that this is the case, it's when k lies between minus 8 and 8. And these are the values of k. And now, what values of k are these? These are, we have to calculate the values of k so that the h of x equals minus 2x plus k will not intersect the graph of G. But if it doesn't intersect the graph of G, it means you have non-real roots. So yeah, pay particular attention to that. Pay particular attention to that. Right, so the next question now is question 5.7. In 5.7, we're saying H. H is a tangent to G at R. Okay, this is actually H. H is this one. So you can imagine, therefore, that H here, you can write up here, is minus 2x plus 8. Okay. Okay, now if this is H, because we've got the K before, it was just close to 8. K was 8 minus 8 as the critical values here, so we just plug it in here. But we're saying H is a tangent to G at R, a point in the first quadrant. So there's a point in the first quadrant such that H is a tangent to G at R, but something like this. But we are sure that this H is minus 2x plus 8. Minus 2x plus 8. Minus 2x plus 8. So, okay, now let's think together, guys, here. Okay, these are past exam questions, so they require a lot of reasoning, some of them. Some are easier, but some you'll have to try and interpret and just sketch and understand what the question is saying, but also look at what the question wants. Because H is a tangent to G at R, and here is H that is a tangent to G at the point R. A point in the first quadrant. So R is a point in the first quadrant. Calculate T such that this is the case. So You need to calculate t such that y is f of x plus t intersects g at r. Intersects g at r. Okay. So if these intersect, how do they then intersect? Because what then do we have at this point? Right, so you need to take into account so that you have your h, and you need to take into account the fact that h is a tangent to g. So it means that h is equal to g at the point of intersection, or at a point of intersection. At a point of intersection, it means those are the same. So we continue to solve more problems here. What do we do together? Okay, if so this, the fact that h equals g, that means that h is a tangent to g at r. Okay, now let's look at these parts. I want us to g at r. I want us to look at these carefully. H is a tangent to g at r, it means they're equal. At the point of tangency, they're equal. Okay, so you make them equal to each other. And h is the same as what? Minus 2x plus 8. G is 8 over x. And then this is minus 2x squared plus 8x equals 8, which means it is 2x squared minus 8x plus 8 equals 0. Okay, you transpose everything and you divide by 2, which means it is x squared minus 4x plus 4 equals 0. You factorize this and you get the square equals 0. And at this point, it means k equals 2. And the fact that h is a tangent to g at r, this is what it means. Because at the point of tangency, so this r is a point of tangency. R is a point. Right, is the point of tangency. Right, so at the point of tangency, then both functions are equal to each other. Now, I want us to look at this, but reason very slowly as we try to understand this question. A point in the first quadrant. So R is a point in the first quadrant. This is the first quadrant. Calculate T such that these are equal. So we got the X, that is the case. But now you have your f of X there. What is your f of X there? So you need to find now f at, right, you need to find now f at 2. Like this. Okay, so we are. Okay, what answer did we get here? We got 2 times 8. Okay, we have 2 times 8, which is 16 minus 1. 15 out of 2. Okay, it means f is 15 out of 2. And then it means that f is 15 out of 2. So if you have that y is f of x plus t, y is 15 out of 2 t, and such that calculate t such that these intersects g at r. If this intersects g at r, it's like h this. It's like h this because it is h that intersects g. What is h at 2? So you need to find h at 2, which means that you're going to find h at 2. What is minus 2 plus minus 2 by 2, which is a minus 4 plus 8? It's a 4, and you put a 4 here. Our t then is equal to minus 7 over 2. Right, and the t here is minus 7 over 2. Our t is minus 7 over 2. And how do we get the minus 7 over 2? We simply say 4 minus 15 out of 2 is minus 7 over 2. Minus 7 over 2. Right, it was awesome seeing you guys. So a very interesting evening we had and a very, very rewarding discussion. We're gonna have more mathematics discussions, I must indicate, moving forward. We're trying to prepare for the junior exams, but I want us to go very, very hard on mathematics and science in an attempt to perfect our problem-solving skills. We're gonna also spend time on financial mathematics and other things moving forward.